All right, so it's time to talk about monitoring. So in this video, remember, we're gonna do exactly what I did before with the training pipeline. In this video, I'm gonna focus on monitoring at a high level. In the next video, I'm gonna dive deeper in the source code so you understand what I did there. So to talk about monitoring, I want you to take a look at this high level diagram here. This is pretty much how monitoring is working here. So we're going to have two data sets. Okay, so data set number one is what I call the reference data set. So the reference data set is the Penguins data set that we use to train our model. Why is it a reference data set? Because we're going to use the information in that data set to determine what we should expect in production. So for example, if the average body weight of a penguin is 5,000 grams, we would like to see 5,000 grams in the production data set as an average later on. If that increases, then we had drift, and that is precisely what we want to report. Monitoring is about reporting any problems in either the traffic data, so the data that's coming to the endpoint, or the model predictions. So if the model starts making the wrong predictions, we want to report that. So here on your left in this diagram, you have both data sets that I'm going to be using here. The reference data, again, is just going to be the training data set that we used. And the production data is the data that we've been capturing from the hosted model. In the previous few previous sessions, we talked about how our custom endpoint, our custom model stores data in a SQLite database. Well, that's what the production data will look like, okay? And then I divided this into two sections. So the first section is going to focus on what can we determine from that production data, the traffic data, the data that's coming through the endpoint. Can we detect any drift? Can we detect any problems with that data? I have data quality here, and I also have data drift. So data quality is looking at every field, for example, independently, and making sure, for example, that I'm not seeing too many null values, right, compared with the reference data. So in the reference data, we had, let's say, 20% of the sex column was null. But now we're seeing 40% of the sex column being null. Well, I might want to report that as something that we need to take a look at. And then the second square here, the second step is just related to data drift. This is the one that's going to determine if there are any values that have changed from the baseline, and that baseline determined by the reference data. That will be what's going to happen within this section of traffic data. And then I'm going to go into the model prediction section, which is pretty much going to do the same thing, but just for the predictions that the model is making. So it's going to detect the quality of those predictions. Is there any drift on those predictions? So for example, let's say that with the training data, my model reported that, I don't know, maybe 40% of the classes are Adelie, right? If now when the model is hosted and making running inference on prediction data, if now all of a sudden 80% of the samples are Adelie, there is drift there. It was 40% before, now it's 80%. So we're going to have to detect that. And obviously, all of these steps are going to produce just metrics and reports that we can check out. Now, for this class, what I did was take advantage of the built-in car server that's provided by Metaflow. Remember that we saw a little bit of this when we did training, that it's basically that web page that you can open and go to every step and see reports and whatnot. So I'm taking advantage of this here so we can see the results of the monitoring pipeline. So in the README file, in order to just run monitoring, oh, by the way, remember, before I go to the README file, in order for you to run monitoring, obviously you need to have some traffic data, right? So we did that in the previous session. I'm just going to check here that that data already exists. So the previous, we have an inference server running here. So this is our server, the one that we're sending samples to and getting predictions back. Remember that server, when we ran the command for the endpoint, that server stored all of that traffic in a penguins.db data SQLite database. So I'm just going to list out that the contents of that database just to make sure that we actually have data inside, okay? If I don't have any data, the monitoring pipeline is not going to do anything because there's nothing to monitor, obviously. So I'm just going to list what's inside. And as you can see, I have 201 samples that I created using the endpoint pipeline. We ran that in the previous few sessions. I'm just going to list here maybe a couple of the columns just to make sure those have labels, because we're going to need the labels in this section of these model predictions. We're going to need labels for that. So let's list the prediction and the label. I think the label was called species. So if we do this, what do we get? There we go. You get all of the predictions that were made and the labels that were assigned to each section or each row. There are some mistakes, obviously, like in this case here, the prediction was Chinstrap, but the labels was Gen2. So hopefully we're going to catch that during monitoring. Okay, so if we have this, now I can just go and run the monitoring pipeline. Now, to run the monitoring pipeline, let's start the car server, the Metaflow car server, so we can actually see all of the reports that the Metaflow pipeline is going to generate. So I'm going to copy this command, which is just going to run the monitoring pipeline with the car server. I'm going to go to this terminal window that I have it here. I'm going to run that. So now this is running on port 8324. I'm going to go to the list of open ports. I have 3 open ports. One, the 5000, is the MLflow server. The 8080 is my inference server. And then 8324 now is my card. So I'm going to open that. That's going to go here. That's going to open the last pipeline. I'm not going to look at it for now. I'm just going to run the pipeline, and then we're going to look at it. So let's take this command. This command is just going to run the pipeline. Notice there is one parameter here that I need to use, which is the data store URI. And this is just pointing to my Penguins database, so the SQLite database that contains all of the data. So I'm going to do that. I'm going to run it. It's going to take a second to run. And when this, as soon as this starts running, we can go, like now, we can go here and see what's happening. This is just the start step. Here in the start step, let's take a look at the artifacts. So we have reference data and we have current data. Now, reference data here is going to be, and by the way, here are the artifacts. So the reference data is basically the training data set. It's just the same data set that we've used to train the model. That's the data that I'm going to use as baseline. And then the current data, so we have here current data. This current data is the penguins.db dataset. This is the production data that we're going to be checking, okay? So let's go. You can see here all of the different steps, and each step here is doing something different. Let's go to a test suite that I'm running. And here we can see that I ran 13 tests just on those 2 data sets. 11 of them succeeded and 2 of them failed. And here you get like a summary of every single one of those tests, and we can see immediately those that failed. So first, the mean value test failed. Okay, so this is the test threshold. You can see the details if you want to. So this is giving me information about the mean value of the body mass that obviously changed. You know why it changed? Remember that the endpoint pipeline had a parameter that's called drift. And I introduced some drift in that parameter. So now this is getting reflected here. This is telling me, hey, the average weight of a penguin changed. And there is another test that's called the number of drifted features. And as you can see here, out of the 4 features that I was checking these 4 features for drift. One of them failed, which is the body mass. So the body mass here, I don't know if you can see that over here, it says data drift was detected. Okay, so this is great because this is immediately telling me that something wrong is going on. Now I have more tests here, more reports. I'm gonna go to the data quality report now. Let's see what we get here. All right, so a lot of information, and I'm sorry, I should maybe make this a little bit bigger so we can actually see what's going on. So a lot of information here. This is a summary of the data set, and here you get the prediction category. It's telling us, like the current data set is 200. The reference data set is 344. So again, this is just giving us just a comparison between the current data set, which is the data that we're seeing in production, and the reference data set. You see the most common, for example, in the current data set is Gen 2, while in the reference data set was Adelie. Adelie was 45%, it was the most common class. But now in production, we're seeing that Gen 2 is more prevalent than Adelie. How many missing values? We have none. No categories, no missing categories. We have all of that good stuff. That's just for the prediction column. It's going to do the same thing for every single column that we get. Like the Coleman length, we see, a comparison. Let's look at missing. Like, for example, in the reference data set, 2 samples had the Coleman length missing. In the current data set, we have 0. So you can see immediately things that changed here. And obviously you have a chart here that's going to make it even easier. So keep going down. It's going to show me all of those values. Okay, look at this. Look at this. This is the body mass. This is the one where I introduced the drift. It says the most common value in the reference data set was 3,800. The most common value in the current data set is actually 57, which is quite larger. Okay, so you can see just by looking at these percentiles here, you can see how the current data set, the body mass is way higher than the one before, right? It's always higher. So that's where the drift was detected. Keep going down, and then we're going to get a section that's called the data set, the missing values for the data set. In the current data, nothing. In the reference data, 19 missing values, which is fine. Okay. And then we get a report that's called the data set drift. Out of 7 columns, it says that 2 columns drifted. Let's see what those 2 columns are. So it says that it detected drift in the prediction column. Remember that now Gen 2 is the more prevalent class instead of Adelie. So it detected that column. It just, the predictions that we're making, there is drift there. And it's also detecting drift in the body mass column. So basically the body weight of the penguin. It detected here drift. And you can see the charts here. And you can even see how this drifted. You can see how they move. The chart moves towards the right, towards bigger values. So this is awesome. Let's keep going. I have a test accuracy score that basically focused on, the accuracy of the model and whatnot. So it says that the accuracy score is 0.85. So that means that my model in production is 85% accurate. However, I wanted this test to trigger if the accuracy of the model was greater than or equal to 0.9. So, sorry, that if it was lower than 0.9, I wanted this test to trigger, okay? So that is why I'm getting an error here, because you can set a threshold, run a test, and whenever the accuracy of your model goes under that threshold, this test will trigger. You can see the details here and see pretty much like a confusion matrix here. That's going to tell you where the problems are. Okay, so cool. Cool. Let's see what else. We have a test drift report. And again, this is just going to run a target drift report. It's going to determine drift in the predictions of the model. So it gives you first the drift in column prediction, data drift detected. Remember, we have two columns that had drift. Prediction was one of them. Drift detection method was the chi-square, blah, 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 chi-square. And then here it tells us what just happened. The reference data set is the gray one, way more add-a-list than we're having right now. That's the problem. Correlations for column prediction, it's going to tell me what are the correlations. So that's probably why we're seeing that drift. And then finally, we get a classification report. The current model, the quality metrics are 85% for the current model. The precision is 85%, 83% recall. The F1 score is 84%. Here's the class representation. And here is a confusion matrix in order for us to just, try to fix that. The quality metrics by class, etc. So all of those reports get generated every time I run the monitoring pipeline. So in a production environment, you can imagine this monitoring pipeline running constantly, and we can monitor those results just by looking at the core server or by accessing the metadata generated by that monitoring pipeline. Every time we run it, we're going to get more data. Now, let's try something where we're going to add more data. Right now, we have 200 samples. Is this what it is? Let me see. Yeah. Current data, we have 200 rows. That's what we're storing in the database. Let's try to add more data, and let's try to use that data with different characteristics so maybe the drift goes away. So in order to do that, we can just go and generate more data without any drift. Okay, so I'm going to generate another 200 samples, but I'm going to say I don't want any drift, so I'm going to set drift to false. So by doing this, actually, there is something else that's on the labels. This is just generating the data. I don't want any drift. And then for the labels, I'm going to change the ground truth quality, and I'm going to set it to 100%. Remember, there is a parameter here that's going to allow me to do that for the labels. I don't remember the name of the parameter, so I'm going to look it up just to make sure I get it correctly. So the parameter name should be, there we go, ground truth quality. It's actually with dashes, just like this. So I'm going to do this, and then I'm going to set the ground truth quality, and I'm going to set it to 1.0. Okay? So this should generate labels for the last 200 samples that we just added. Okay? Now, the monitoring pipeline, and we're going to dive into the monitoring pipeline later on. The monitoring pipeline, by default, only uses the last 200 samples. So if I don't change this value here, the monitoring pipeline will be using these 200 samples that I just created that should have no drift in order to just do the monitoring, just to run the report. If I extend samples to, let's say, 400, now I'm going to also be using the 200 samples that I had before. All right, so how do I do this? Let's do SQLite 3, and then let's open the Penguins DB, and then let's make sure that we have the data that we just added. So I'm just going to count how many rows we have inside, and we have 401 row, which is exactly what we needed. And now we can run the monitoring pipeline. So let's just copy the command. I should have it somewhere, but I'm just going to copy here. Again, this should use the latest 200 samples to do the monitoring. And what I'm looking at here is, well, supposedly we should not have drift because it should be looking pretty good. Well, maybe there is drift in the prediction column just because we're seeing more Gentools than add-a-list, but at least the body mass should not have any drift because we did not introduce any drift there. All right, so let's wait for this to finish. Let's open this test suite, loading the results. And as you can see here, 13 tests, 13 of those tests succeeded. Now the number of drifted columns here, remember, I'm testing 4 columns here. Those are these 4 columns, and now body mass does not have any drift. Why? Because I submitted data without any drift. Okay, so this is pretty cool. I mean, we can check everything else, the data quality report. We can check all of that good stuff. Let's see, prediction here. Look at this. The prediction, even the most common one, is fine. So we didn't get any problems there. Target drift. Data drift was not detected in the column prediction. So even here, we did not get any drift, which is awesome. Cool. Awesome. So that is how the monitoring pipeline works. Okay. So in the next video, we are going to go into the code and I'm going to show you how I built all of that. I'll see you in the next one.